Hello everyone, my name is S.N. Patil. In this video lecture, we will discuss on the topic difference equation. Here we discuss the problem on the difference equation. The problem is solve the difference equation. So for the solution set, this is the non-homogeneous difference equation. The solution, complete solution of this difference equation is general plus complementary. Let me clear you. In differential equation, the solution is complementary plus particular integral. So here we use the different word. Okay, so remember it. Let y suffix x plus 2 x plus 2 minus 4 times x plus 1 plus 3 times y suffix x is equal to 3 raised to x plus 1. Say equation number 1. For general solution, we require the auxiliary equation. For that, put y suffix x is equal to m to the power x. Then auxiliary equation is, see, after putting this and simplify, then we get the auxiliary equation m square minus 4m plus 3 is equal to 0. So here we get the roots m is equal to 1 and 3. Let us verify. The addition of the roots is always minus times second coefficient, and the product of the roots is always the constant term. Okay. If even degree, then as it is product, and if odd degree, then minus time. Okay, remember. So here, the first root we say m1 is equal to 1, m2 is equal to 3. We get the distinct root here. Then it's general solution y suffix x is equal to c1 m1 raised to x, c2 m2 raised to x, that is y suffix x is equal to c1 1 raised to x plus c2 3 raised to x. Now proceed for the particular solution. So 1 upon, in auxiliary equation, instead of m, write the e square minus 4e plus 3 is equal to the right hand side 3 raised to x plus 1. So there are two terms. The inverse operator operate on the both two term. That is the linearity property. So here in a denominator, there is a quadratic equation. Instead of that, I am write the distinct factor. Okay. So the factor is, if root 1 and 3, then factor is m minus 1 and m minus 3. It can be written as 1 upon m minus 1, m minus 3, and which is multiplied to the first term plus multiplied to the second term. Second term is simply 1, m minus 1, m minus 3. Whenever 1 is there, constant term is there, then we write 1 raised to x. Okay. Now see here what happened. We have the property. If inverse operator operate on a raised to x, then put e is equal to a, and provided that phi of a must be non-zero. Here what happened, when we put e is equal to, sorry, this is the e term. I am writing this is the e. E minus 1, e minus 3, e minus 1, e minus 3. Okay. When we put e is equal to 3 here no problem in first factor, but here 0. Similarly, when we put e equal to 1 here, then 1 minus 1 is 0. So here we get the 0 in both cases. So we have the another formula for this. 1 upon e minus a raised to n, and now I'm putting the general formula, a raised to a, then x, see the power is n, then x minus 1 up to x minus n minus 1, that is the minus sign is multiplied, divided by n factorial and a raised to x minus n. Okay, so we use this formula. And for particularly for one order, 1 upon e minus a raised to x, then here x divided by 1 factorial, okay, and here a raised to x minus 1. Okay, this is the n factorial. Now, the particular solution is equal to, now here 1 upon 3 minus 1. Okay, so here no problem for first factor. Now second factor we apply this formula, that is x, okay, divided by 1 factorial and 3 raised to x minus 1. Now plus, for first factor no problem, this is 1 minus 3, and apply the formula x 1 factorial and 1 raised to x minus 1, that is 1 upon 2 x 3 raised to x minus 1 minus 1 by 2 x 1 raised to x minus 1 means 1. So here common term is 1 by 2 x, and remaining here 3 raised to x minus 1 minus 1. So complete solution y suffix x is equal to general solution c1, 1 raised to x is 1 into c1 is c1 plus c2, 3 raised to x plus 1 by 2 x 3 raised to x minus 1 minus 1, which is required solution. Okay, thank you. Thanks for watching the video.